Hello dear students, I am your educator Burhanuddin and it's time to cram. So student, this is the first video of series chapter 12 electricity of class 10 and I will try my level best to make every topic easy to understand with the help of virtual representation. So in this first video, I am going to take introduction of this chapter, then we are going to understand what is electricity or electric current, and according to your textbook section 12.1 electric current and circuit. Let's recall some component you learnt in your previous classes: bulb, battery, switch, wires. So you are familiar with these components, but now we are going to learn about following components in this chapter. Those are resistor, emitter, voltmeter, diode and many other components. We will see that what is the use of this component in an electric circuit, how they work. We will cover all these things in this series. So before going to chapter, one should know what is the difference between conductor and insulator. Hope everyone know, but let's recall that the conductor allows electric current to pass through them. Okay, but the insulator do not allow electric current to pass through them. Then conductor have electric charges free to move, but in the case of insulator, electric charges are not free to move. So, if we talk about conductor, when some charge is transferred to a conductor, it readily distributes over the entire surface. When some charge is transferred to an insulator, it remains at the same place over the surface. It means that insulator will not allow those charges to move further. Due to that, insulator do not conduct electricity, and most metal are conductor and most non-metals are insulator. So the very easy example to understand difference between conductor and insulator is wire. Wire consists of conductor and insulator both. So as you can see here, the copper wire used in wire is metal and it is used to conduct electricity. Those copper wires are coated with the insulator to prevent flow of electric charge in the environment, or if you touch the wire you will not get shock. So this is the best example to understand difference between conductor and insulator. Hope it is clear to everyone. So now let's see what is electric current. So electric current is rate of flow of charge. It means how many charges are flowing through a conductor in some time, or you can also say motion of electron in the conductor. It is known as electricity. So the question should arise in one mind that if we talk about charge, so there are two types of charge: positive charge and negative charge. So why we are talking only about electrons? So we will find the answer of this question further in this video. So now let's see definition of electric current according to your textbook. It is, if a net charge Q flows across any cross section of a conductor in a time t, then the current I through the cross section is I is equal to Q by T. Before few seconds I told you that electric current or electricity is rate of flow of charge. So what does it rate define? Rate defines means in particular time. Okay, the flow of charge in particular time is known as electricity. So I is current, symbol of current is I, and the unit of current is ampere, capital A. Q is a symbol of charge and unit of charge is coulomb, capital C, and T is a symbol of time and its unit is second, small s. So SI unit of current I will be 1 ampere is equal to 1 coulomb per second. Note, 1 coulomb is approximately equal to 6.24 into 10 raised to 18 or 6.24 quintillion. Also, 1 milliampere is equal to 10 raised to minus 3 ampere. and 1 microampere is equal to 10 raised to minus 6 ampere. You should remember this. Value of micro is 10 raised to minus 6 and value of milli is 10 raised to minus 3. It will be useful for solving sums. Now let's understand motion of electron. So it is said that flow of electron inside a conductor is opposite to flow of direction of current inside a conductor. As I told you before also that if flow of electron is from left to right, then the conventional flow of current will be from right to left. Hence, it is known as conventional current flow. Let's understand flow of electron inside a conductor. So, according to Dord and Lorentz, conductor have more number of free electron. At the same time, the positive ion doesn't move. They are fixed at their location. So, due to that, we only talk about flow of electron inside a conductor because positive ions doesn't move inside a conductor. They are fixed at that position. Thus, the arrangement of positive ions is known as lattice. You can see here. So, do you know the net charge flowing through any cross section of a conductor is 0? Why? Because the number of electrons flowing through the cross section of a conductor from right to left in 1 second is equal to number of electrons flowing from left to right. Due to that, the net charge flowing through any cross section is 0. This might be asked in 1 marker question. So, if bulb glows when it is connected to a battery, then electrons are responsible for energy transfer between the bulb and battery. This motion of electron is known as electric current. An instrument called emitter measures electric current in a circuit. It is always connected in a series through which current is to be measured. Mind well, it is connected to the series. So if you want to measure current inside any circuit, so you have to make use of emitter. According to the textbook, figure 2.1 shows the schematic diagram of a typical electric circuit comprising of a cell, an electric bulb, an emitter and a plug key, or you can say switch also. Like this, you have to connect emitter to know the current flowing inside a circuit in a series connection. But you should remember that the electric current flow in a circuit from positive terminal of the cell to the negative terminal of the cell through the bulb and emitter. The flow of current inside a circuit is from positive terminal of battery to the negative terminal of the battery. This is a very important thing which you should know. So, let's see what did you understand. With the help of example 12.1, a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So, write the data given. Value of electric current is given to us, that is 0.5 ampere, and time is 10 minutes. But remember one thing, you should always take time in second only. So convert this 10 minutes to second, it will give 600 second. Now you know the formula that I is equal to Q by T. So now from here you are given with electric current and time. So you have to find charge. So in this equation make Q as a subject. Take T from RHS to LHS. The equation will be Q is equal to IT. Now substitute the value of I and T in this equation, then you will get value of charge, that is 300 coulomb. So like this, with the help of this equation, you can find any value if two values are given. So if in the question value of charge and time is given, so substitute the value of charge and time in this equation, you will get value of current in ampere. If you are given with the value of current and charge, so from this equation make T as a subject and substitute the value, you will get the value of time. So this was the introduction of the chapter electricity. Now the topic which will be covered in next video lecture is drift speed. Notes are uploaded on the bloggers page of Time to Cram. So visit the bloggers page to download the notes, and the link of the bloggers is given in the description box. So check the description box, get the link and download the notes. And if you find this video helpful and informative, then like it and do share it with your friends and classmates. And yet you had not subscribed to our channel Time to Cram, then subscribe it and don't forget to hit the bell icon so that you will get latest notification and update when new video is uploaded. That's all for today's video lecture. Thank you.